Hi guys, welcome to Solve It. So today we're going to be working on problem 17 from AMC12A 2023. So here's the problem. Flora the frog starts at 0 on the number line and makes a sequence of jumps to the right. In any one jump, independent of previous jumps, Flora leaps a positive integer distance m with probability 2 to the m over 1 over 2 to the m. What is the probability that Flora will eventually land at 10? Okay, so first of all, let's draw a picture to get a sense of what's going on. So we have a number line, 0, and so the frog is going to be making sequence of jumps to the right. So notice that it's going to always jumping to the right without making any of the left jumps. And each jump is independent of the previous jumps. And for a distance of positive distance of m, the frog's gonna be jumping with probably 1 over 2 to the m. So now we're gonna be looking for the probability that the frog is gonna be eventually be at 10. So let's declare some variables. So we can first let p sub 0 to be the probability of eventually landing at 10. Starting at 0. And so on. So p sub I is going to be the same thing, except that it's going to be starting at I. So our goal is to find out what p sub 0 is. And to do so, one of the way would be working backwards. So we start from like a really base case, like the simplest case. So whenever you're trying to solve a problem like this, you want to consider the simplest case that you can think of. So in this case is that the Flora is going to start at 10. So we can first consider p sub 10. So what's the probability that she's going to eventually land at 10, starting at 10? And that's pretty trivial. So it's going to be 1. Okay, so now let's focus on p sub 9. So for p sub 9, if we're starting at index 9, so we're here, and in order to land at 10, we're going to make a jump of distance 1. And the chance of that happening would be 1 over 2. And that's the only way for us to get to 10, starting at 9. And so it's going to be 1/2. And for p sub 8, we have 2 ways of getting to 10. One being we jump from 8 to 9 and then to 10. And then the other being we make a jump of distance 2 directly to 10. And for the first case, we're making 2 jumps. It's going to be so for us to make this jump from 8 to 9, it's going to be a distance of 1. And so that's going to be a probability of 1/2. And the probability of making it from 9 to 10 is going to be p sub 9. Okay, so that's one of the ways that we can land at 10. And then for the second case, it's going to be directly making a jump of length 2. And that's going to be 1 over 2 to the 2. Because the distance is 2, and it's given by this probability. And so we can just plug in whatever we have for p sub 9 to compute p sub 8. So it's going to be 1/2 times 1/2 plus 1 over 4. And this is going to be 1/2. Okay. And then let's do one more case. P sub 7. And similarly, for P sub 7, if we're going to start at 7, we have several ways to getting to 10. So we either make one jump to 8 and then getting there and using P sub 8 to help us to compute the probability, or we can make a jump of 2 to 9 and then use P sub 9 to compute for us. And then the final one is jumping from 7 to 10 directly of length 3. And so this is going to be look like, so let's consider making a jump from 7 to 8. That's going to be 1/2 times P sub 8. And then the second one would be jumping to P sub 9. Jumping to 9. That's going to be 1 over 2 to the 2, because it's of length 2, times P sub 9. And then the final one being making a jump of length 3 with probability 1 over 2 to the 3rd. And so we plug in the numbers for these, for P sub 8, 9, and P sub 9. That's going to be 1/2 times 1/2 plus 1/4 times 1/2 plus 1 over 8. So it's going to be 1 over 4, 1 over 8 plus 1 over 8. And so it's going to be 1 over 2. And you can kind of see this, there's a pattern going on. So it's 1/2 for P sub 9, 1/2 for P sub 8, 1/2 for P sub 7. And so you can make an induction argument that eventually everything is going to be 1/2, 1/2, and so on. And so eventually for P sub 0, we're going to get 1/2 as our answer. Okay, so this problem is like we make use of like a recursion. There's a recursion going on here, and we make like a induction argument here to conclude that P sub 0 is the probability that the flora will eventually land at 10 would be 1/2.